In this video, we are going to be exploring how to solve exponential equations using the definition of a logarithm. So in a previous video, we talked about solving exponential equations when we could make our bases be the same. So in that case, we might have 2 to the x, something very simple, equals 4. And we could rewrite 4 as 2 to the second power, so 2 squared. Since the base is the same on each side, those kind of undo each other. Since we know that the bases are equivalent, that means the exponents must also be equivalent. So we could just rewrite the equation with exponents. So x equals 2, and that gives us our answer. So our first method or technique or process was to get the bases to be the same on each side of the equation and solve. If you look at number 1, you can see that the base on the left is 3 and the base on the right is 4. There's no way that we can make these be the same. So we can't rewrite 4 to a power and 3 to a power where they're the same base. So that method is not going to work in these examples. So the other way we can do this is use the definition of a logarithm to solve. This works if you have one exponential expression within your equation. So this technique, I know to use this one if I see one exponential equation. So for example, in number 1, if I had the addition of this, so if it was 3 to a power is equal to 4 to a power, the method that I'm about to explain wouldn't work. I'd have to do something slightly different. But as long as I have only one exponential, what's on the left is an exponential and what's on the right is not, I can use this method. So I want to make sure that the thing raised to the exponent is by itself. So the exponential expression should be by itself on one side of the equal sign. Once it is, I'm simply going to rewrite it in logarithmic form. So identify the base, that's the first step. Start by writing log base 3, so the base is a subscript, of 4 is equal to 5x minus 8. So in a previous video, we talked about rewriting an exponential equation in logarithmic form, and this is when we actually will use it to solve an equation. So we start with an exponential, we rewrite it in log form, and now our goal is to get the x by itself, and that will be our solution. So we can add 8 to both sides. So that's going to be log base 3 of 4 plus 8 is equal to 5x. So a common mistake is people want to add the 4 and the 8 and say log base 3 of 12. You cannot add those because they're not like terms. The 4 is in the argument for the log. The 8 is not, so don't add those up. Don't make that mistake. And then the last thing to get the x by itself is to divide by 5. So we get x is equal to log base 3 of 4 plus 8 all over 5. This is our exact answer. So this is the exact answer. If we want an exact answer, then this is what we type in. If you want to know a number, you're going to get some decimal. So you could put this in your calculator and get that, and that will be the estimate. So probably in your homework, it will ask you for the estimate. So let's add some parts to the directions. So solve, round your answer to the nearest hundredth. So let's just say hundredth. So that's 2 numbers after the decimal place. So I'm going to type this in my calculator and see what I get. So when I typed it in my calculator and I'm rounding to the nearest hundredth, I get 1.85. So that would be my estimate or my answer rounded to the nearest hundredth. So let's look at number 2. Number 2, I'm trying to solve this exponential equation. Hopefully the first thing you notice is that the exponential expression is not by itself. So if I'm looking for the exponential expression, it's the base raised to the power. So what I've just highlighted in red is what I'm trying to get by itself. So before I can rewrite in log form, I need to isolate that red section, the base and the power. So I need to get rid of that 2. Since it's 2 times that expression, I'm going to undo that by dividing. So I'm just going to divide both sides by 2 first. So that'll give me 6 is equal to 5 to the 3x plus 1. Now that I have the exponential expression by itself on the right-hand side, I can rewrite this in log form. So I'll start by writing log, identifying the base. So log base 5, go across the equal sign, of 6 is equal to, go across the equal sign, 3x plus 1. So now I'm going to solve for x. So subtract 1 from both sides. So that'll give me log base 5 of 6 minus 1 is equal to 3x. And to finish, I'm going to divide both sides by 3. So x equals log base 5 of 6 minus 1 all over 3. So that is your exact answer. And if you want an estimate, you would put this in your calculator, and you would see that you would get approximately 0.04 rounded to the nearest hundredth. So let's look at the next one. We've got 2 more that I want to walk through with you. Number 3. So first you want to decide if the exponential is by itself on one side of the equal sign, and it is. The left-hand side is just an exponential expression. So we're good now to start by rewriting in log form. So I'm going to write log base 10. Since it's base 10, that's the understood base, so I don't have to write it. Go across the equal sign of 2 is equal to 4x. So this time all I need to do is divide by 4, and I will get my answer. So x equals log of 2 over 4. So that's my exact answer. And I could get my estimate by plugging that in the calculator. And when I do that, I get 0.08. So it's 0.75. The 5 after the 7 will round it up to an 8. So 0.08 with appropriate rounding to the hundredths place. All right, last we're going to do number 4. So this one, you can see that the exponential expression is definitely not by itself. So your first goal is to identify what is the exponential expression. So in this case, it's e is the base raised to the negative x plus 2. So that is what you're trying to get by itself. So the first thing you will undo is the addition or subtraction. So we would add 1 to both sides. And we would get 3 times e to the negative x plus 2 is equal to 6. Still trying to get that e to by itself. So we would want to divide by 3. Since we're multiplying by 3, we undo that with division. So we would have e to the negative x plus 2 is equal to 2. I now have my exponential expression isolated on the left. The e to the power is by itself. Remember that you're identifying the base. In this case, it's e. When you identify the base of e, you use the natural log. So we're going to do the natural log of the natural log base e of 2 is equal to negative x plus 2. And so to finish getting the x by itself, we would want to subtract 2 from both sides. So we would have the natural log of 2 minus 2 is equal to negative x. And then we don't want the x to be negative, so we would divide by negative 1. and we would get x is equal to a negative ln of 2 plus 2. That's your exact answer. If you want an estimate, or if the directions tell you to round your answer, that means you want an estimate. Rounded to the nearest hundredth, it would be 1.31. So it's 1.306. So the 6 after the 0 rounds it up to a 1. So 1.31.